Hi, my name is Scott Simpson, and today we'll be talking about Avogadro's number. So Avogadro's number is a number that comes up quite a bit in chemistry, and it's actually like a title of how many items are in something. So it's sort of like how a baker's dozen is 13 items. Avogadro's number is just a number of items. It's 6.022 times 10 to the 23rd items. So, Avogadro's number. And again, we shorten that to n sub a, so sometimes when you look in different textbooks or different reference sheets, you'll probably see the symbol n sub a for Avogadro's number, and it's the number of particles that are contained in 1 mole. So 1 mole will have 6.022 times 10 to the 23rd items. A lot of times we'll say that these items are either mole or molecules or number of atoms, but it really can be any number of items. It is a really large number of items, so for example, if you were to say that we have 1 mole of cats, that'd be 6.022 times 10 to the 23rd cats. It's a ton of animals. So as an example, let's try to look at an interesting dimensional analysis problem where we consider the number of legs on a spider. So, example, how many spider legs are there in 0.250 moles of spiders, assuming each spider has 6 legs? So again, the approach that I take to all these problems, I box what we're looking for and I underline important information. So we're looking for how many spider legs, the information that we have that's important to us. We know we have that many moles and each spider has 6 legs. So let's start with what we know. We know we have 0.250 moles of spiders. We're not at the unit we desire yet, so we got to multiply this by some fraction. We know that this unit in the denominator has to match that unit. I always suggest for people to look at the units first, then look at the number. So we're going to have moles of spider beneath in the denominator. And we can convert to mole, or actually numbers of spiders from this. So spiders. We have 1 mole of something. We've already discussed how many items we have in there. We have 6.022 times 10 to the 23rd of those items. So if we have 1 mole of spiders, that means we have 6.022 times 10 to the 23rd spiders. However, we're not quite at the answer we want. We want to get to legs, so we have to have another unit conversion along the lines. We know what unit has to go down here because it has to match this guy up here. We know we have to have spider. Spider is down here. And then we're trying to get to legs, so let's just put legs up top. Let's see if we can do something. We had said each spider, we're assuming each spider has 6 legs, which is kind of ridiculous because spiders have 8 legs, but we're going to go with that. 6 legs. I guess we could change this from spiders to scorpions, but we'll leave it as it is now. So we multiply that through, what we end up getting is 9.033 times 10 to the 23rd legs. However, this isn't the answer we want to report. We want to keep significant figures in mind. So this value here, this has 3 significant figures. This number is actually empirically derived, so this Avogadro's number has 4 significant figures. There are more decimals past that 0.022. And as we look at this value, these are exact numbers for exactly 1 spider. We have 6 legs. So we're limited by the number of sig figs of our original number, which is 3, so we got to approximate this to 3 sig figs. So therefore, 9.03 times 10 to the 23rd legs is the answer that we'd want to report. Okay, Well, let's get to something more chemical. Let's consider a mole of sulfur atoms. Okay. Oops. There we go. All right, given the average atomic mass of sulfur is 32.065 AMU per atom. What is the mass of 1.000 moles of sulfur atoms? So we're going to ask that question. Now, if we look at an individual sulfur atom, we know it will never weigh 32.065. That is a weighted average considering all the isotopes. But if we look at a large number of atoms, such as a mole, we can use this number because it will get averaged out that way. And we're not considering just a single atom in that case. So let's take the same approach we did last time. Let's underline what we're looking for. We're looking for the mass. We didn't say in what unit. Let's go for grams. We know we have 1 mole of sulfur atoms, and its average mass is this. So let's start with what we know. We know we have 1 mole of sulfur atoms. We have to do some sort of unit conversion. This unit has to match that unit, so we're stuck with moles of sulfur down there. We could go to atoms, so sulfur atoms. So for every 1 mole of sulfur, we know we have 6.022 times 10 to the 23rd atoms. Because again, we said, we'll make that a better 3. We said that as long as we have a mole of something, we have that many items in there. Okay, so now, still not at the unit we want to get to grams. Let's convert. We know we have to have sulfur atoms in the bottom. Let's get to AMU, because we know for every 1 sulfur atom, on average, we're told that we have 32.065 AMUs. Okay, but we're still not in grams yet, so let's convert over to grams. We know we have to have AMU in the denominator here. We'll convert to grams in that case. You can look this conversion up, but for every 1 AMU, it's 1.66054 times 10 to the minus 24 grams for every 1 AMU. Okay, when we multiply that through, the result I get is 32.06 grams. This is kind of interesting because if we look at a mole of any substance, what we find is that its mass matches its average molecular weight, except instead of being in AMU per atom, it changes from grams per mole. So that's very useful because at the laboratory scale, we're not usually looking at AMUs, we're usually looking at grams. So that's an important point. So using the periodic table, we know the molecular weight or molecular mass of 1 mole of atoms of a particular element. So that way, when later on when we're starting to calculate molecular weights of different structures beyond just single atoms of molecules, we can get a molecular weight easily, and we can use that in terms of grams, because that's what we're going to use in the laboratory. So thank you for watching. If you have any questions, please send me an email or leave comments below. Thank you.